Hi, Stuart here, today with a cloud checklist. You've probably heard this a lot, but over the last 10 to 15 years, I've been involved in more cloud projects than I can count. And the ones that succeed all have the same characteristics. And the ones that fail or never achieve their full potential don't. So this video is very much a personal narrative about the things that I consider to be indispensable in considering putting an application into the cloud. So here's the high-level checklist, which you can refer back to, and we're going to talk through each of these items. Let me just say this. There is no cutting corners. If you want to get the full value out of your application system in the cloud, then you have to do all of these things and do them well, or you will spend your project time in misery instead of having a project that's smooth and successful and delivers business value reliably and consistently. So let's talk networking for a minute. It's appalling how many cloud projects I see where building a network in layers based on intelligent subnetting and network controls of various kinds are neglected. I've seen projects that have run for over a year, and their networks are both porous, which means that outside things can get into the application system through the network that shouldn't be allowed to, and promiscuous, that is to say, no internal controls between the different tiers or layers of the application, and that has an impact not just on security, but typically it's a sign that you're going to have supportability problems, performance problems, and reliability problems. If you're going to have something that faces the internet, then there is no substitute for implementing a WAF. WAFs are different than regular firewalls because typically they're SaaS offering that span a fair fraction of the internet and can do things that regular firewalls cannot. They can enforce OFAC rules or geofencing. They can protect against distributed denial of service attacks. Because all the web application firewalls from a vendor, and typically also collaboratively with various Western security agencies, exchange information about threats and bad actors, they can have a global awareness that you can't get any other way. You need a DMZ, and the things you put in the DMZ should be very carefully considered. Typically, your web servers that provide UI are in the DMZ. Other things, other interop things between your system and other systems are typically in the DMZ. It's not uncommon, for example, to have a web services facade pattern where there is a web service facade that is used for integration and interop that you can evolve the contracts on separately from the services that you would have in your app tier. Typically also that is facilitated by an API gateway, Apogee being my personal favorite. And we want to have firewall rules and traffic shaping rules between not just the tiers, but we want them to be fine-grained even within the tier. If there's no reason for the web servers to talk to the FTP, SFTP gateways, then you shouldn't allow that traffic, and so on. If there's no reason for this group of web services to talk to that group of web services, you shouldn't allow the traffic. If there's no reason for web service B to talk to database A, you shouldn't allow the traffic. Fine-grained permissions allow your head to hit the pillow at night with at least some degree of confidence that traffic will be shaped and flow only to those things that are appropriate in a chain of calls that is manageable and monitorable. So that means that table stakes includes network monitoring, intrusion detection, anomalous traffic detection, plus you want to make sure that you're routinely conducting penetration and other types of security testing and validation on your network and indeed all of the infrastructure built on top of the network on a regular basis, and that you remediate the findings aggressively. Bad actors in the universe are always at work. And never forget that a fair fraction of those bad actors work for you. So you have to provide internal as well as external security controls and auditing. There's no excuse for not doing this. Don't provision infrastructure manually. Have automation. There's lots and lots of great infrastructure automation tools. And depending on your cloud, the tools that are available can vary, but one thing that doesn't vary is you should always pick something that is a mature, well-adopted, well-accepted infrastructure framework that is also a good fit for the cloud or clouds upon which you are provisioning. Shouldn't provision anything without change management. Now, it's okay to have a sandbox environment and let people have a pretty free hand with it as long as you have reasonable cost controls and policy management. But anything that's going to flow outside of that sandbox, even your official developer integration environment, but certainly your QA, UAT, and prod environment. And again, those are the minimum 4 environments. Most cloud projects have more. It's important that before you allow that infrastructure to flow through your environments, that you have both approval through your change management or governance process and full automation and rollback. Human intervention should be required for approval, but not for execution. And whatever you use should provide you a full audit trail, and you should be able to reverse the provisioning, and you should be able to provision and deprovision and test that deprovisioning restores where you were to a stable and usable state. Manually maintaining your inventory of infrastructure is ill-advised. They get out of date incredibly quickly. So having infrastructure discovery and documentation reporting tools, which are provided by most clouds, pretty much out of the box, is the way to go. And when you're looking at infrastructure, you're looking at application topology, networking, whatever, you should always be trying to look at a freshly discovered set of data so that you're not envisioning how you think it should be, you're visualizing how it is. Everything I said about infrastructure monitoring and infrastructure provisioning applies to applications too. You should have a monitoring, logging, and awareness plan and the appropriate governance. And you should think hard about retention of that. In lower environments, a week is fine because typically in lower environments, you're asking, well, what happened when we deployed this to here? But in the upper production environment, and sometimes in UAT, you want to have a much longer retention, and ideally your MLA software package or packages, and here I caution you to avoid best of breed disease by having multiple vendors involved that may not necessarily play well together, and be able to extract that data into cold storage so that later on you have what you need to do investigation, particularly if it involves repudiation or if there is an accusation that your application or infrastructure was vulnerable. And sometimes those vulnerabilities are false accusations and other times they're not. But having kept those logs, you can conduct a forensic examination and find out what the truth is. I'll point out that the way most developers write applications are incredibly hard to figure out what's going on. And that's because typically developers are not good at writing detailed, actionable logs using the right ITIL levels for logging, and I have a video on that you can go watch. Also, you want to consider having them put in timing and eventing. Events are often very interesting to the business because they can be fed to metric aggregation systems, and so you can measure things not only in user behavior, but in, for example, transactions throughout different parts of the system. And whatever logging you have of any kind, make sure InfoSec and compliance uses the appropriate manual inspection and tooling to make sure that the content is not inappropriate. I once saw a system where I was able to go and guess where the weblogs were based on the information about the technology embedded on a page. And from that, I was able to request the weblogs off the disk of the web server. And I discovered that a developer was logging the username and clear text password of everyone who logged in, and they meant it to be turned off in production, but it wasn't, which means they leaked all the usernames and passwords to the internet effectively. Having retention of those logs in production will allow you to see if you had any visitors from where that went to, for example, the /logs directory. Parenthetically, logging to files is an anathema. You should log to streams. I have videos about that too. High availability should exist and be tested. High availability doesn't exist if it's not tested. Same with disaster recovery. So you should have a detailed step-by-step business continuation plan and exercise it. And more than that, it's good to, if your organization is sufficiently mature, do chaos testing too, e.g. something like Netflix's Chaos Monkey that unplugs things. One of the ways to test high availability is, if you can, unplug one of the members of a group of things and make sure things still work and there's no loss of units of work or data. I'll point out that way too many organizations trust their backup technology without ever verifying, and not just running the verification tool, but literally, if you've got a well-run organization, restore the data to somewhere else and have a mechanism that does a snapshot compare so that you can make sure that you can actually get data back out of your backups. One of the things that I found at a customer was they had a critical database that was backed up, but the humans that managed the crypto keys for the backup no longer worked for the firm, and no one had any record of what they were. And the backups were all blenderized bits because cryptography makes the data in it opaque. And so their backups, although they were present and the verification tool said, yes, they are intact, but you couldn't actually get any data out of them because you couldn't provide cryptographic evidence needed to decrypt it. When you're thinking about HADR and business continuation, also consider regionality and compliance, and of course, the security of the backups and key store redundancy and security. So really good key store mechanisms involve multi-human valid requirements to get at the root key, frequent key rotations, key store redundancy over a wide geographic area in its encrypted format, and other kinds of security controls. You want single sources of truth for things. There's this thing called Siegel's Law. That is, a man with one watch knows what time it is, but a man with two watches is never sure. You should never be unsure where the single source of truth is for any given thing in your system. And by the way, that also applies to application data, right? And I am going to do some videos about data modeling and microservices and domain-driven design in the future, but we'll start with just saying that application configuration and secrets should come from one place. So should infrastructure configuration and secrets. So should the run book, the business continuation guide, the DevOps wiki, the developer wiki, etc. And you should have one source control system, a modern one, And I'll put a stake in the ground and say the only acceptable one is Git. But you should have multiple small repositories that are purpose deployed. And I'll have videos about strategies for doing that and the benefits coming up. And you really want to have a single technology stack for managing your source control. You may write your applications in a variety of languages, but you really want to have one authoritative application management platform that ideally contains your source control, your continuous integration, your continuous deployment, your continuous testing, your continuous linting and security scanning. And then you may have a parallel system, a different system that does your infrastructure. That's okay, because each thing has a single source of truth. One of the hallmarks of really good cloud programs is that they strive to make as many things as possible somebody else's problem. And so platform as a service and container as a service for the code that your team writes, or the databases or other enterprise components that your application system depends on, is a really good strategy. Software as a service can be a good strategy too if it's reputable and stable. But remember, if they break, you break. And if that SaaS product is outside of your cloud platform, you now have an opportunity for a lot of finger pointing between vendors. So when possible, limit that as much as you can and avoid virtual machines if you can help it. These days, there's very little that you can't get software as a service or platform as a service. Even things that traditionally you never imagined would ever be that way, including ERP systems and CRM systems and things like that. Almost everything is available, software or platform as a service. And you should try to do that, because when you have virtual machines, you now own a pet. So instead of having cattle with numbers, you now have pets with names. And keeping the system software, operating systems, the third-party vendor products, and everything else up to date and patched and stabilized is a chore. Yes, you can automate it. Yes, you can take the pain out of it, but if you have something that has a manual installation or upgrade process, you've introduced a world of pain, because there's a chance that from VM to VM, you won't be able to have the same repeatable process. And if you have a software product that can't be load balanced or clustered, in other words, made highly available, that's a very high risk thing that you need to think long and hard before you adopt. Continuous everything and move everything left. In a perfect universe, the top 6 things happen on the developer or QA's desktop, and everything gets recapitulated in one or more of the pipelines, or in your monitoring, logging, and awareness system. So all of these things, right, should be continuous. And by continuous, I mean when a CI build gets triggered, we may not trigger one of those for days or weeks if a product is stable and up and running. But when it is triggered, it should be automated. It then should kick off a deploy, which kicks off, right? So the more you can move things left to bring them to the attention of the developer or the platform owners or DevOps or business operations or business data operations, the better off you are. And the more these things become continuous and available on a single pane of glass, which may just be a web page with links off to other single panes of glass. But everybody should know where that one thing is, that is the Rosetta Stone to go and look at the results of everything else. Builds, security scans, health monitoring, synthetic transaction reporting, performance analysis, right? You can have a single page with links off to other things, that's fine, but there should be one place where any of the stakeholders can start and then go from there. And that's a great thing, because as your tooling evolves or maybe even changes, that one web address like quality.projectname.yourorg.whatever will always be the same. It's a permalink that allows people where to start. And if that thing can also roll up into a dashboard or dashboards that are role appropriate for each of the stakeholders, even better. And just be cloud native from the start. And here are some of the success things that we have found, I have found especially, are some indications that you're cloud native. And I have videos on a lot of these things you can go watch, but the one I want to call particularly is if you find you're doing deployments quarterly or half yearly or worse, yearly, you have done a very bad thing because you've created an awful lot of risk. And there are scenarios where, for example, I've had customers that were contractually obligated to only deploy on the 4th of July and Christmas Day. That's bad business planning. But if that's the universe you live in, then you should be deploying frequently to UAT and continuously testing that. So when you deploy from UAT to production, it's flawless. But somewhere, ideally production, but somewhere you should have something that's always got the latest releasable code in it, that's always fresh and is signed off by the business and ready to go live for your end users. I don't know how many times I've been in meetings with customers about, particularly product owners, about security and quality. And they said, well, let's just get the feature out the door and we'll go back and fix it up. First thing is, that never seems to happen. We never get the opportunity to fix something up until something horrible happens. You have an incident in production. You have a customer satisfaction issue. You have a compliance issue. You have a contractual issue. And now you have a fire drill where the business expects everyone to drop everything they're doing and go fix this thing that could have been prevented if security and quality had been baked in every line of code, in every infrastructure provisioning, in every deployment from the word go. If you don't have time to do it right, you'll never have time to do it over. My name's Stuart, and I do a lot of cloud.